This is lesson 1.4, Polynomial Functions and Rates of Change of AP Precalculus Unit 1. A polynomial function is any function representation equivalent to this form, which is the general form. This is the general form. This is the general form for a polynomial function where n is a positive integer and a sub I is a real number for each I from 1 to n, and a sub n, it must be non-zero. Why? Because if a sub n is 0, 0 times the highest power becomes a 0, so we will eliminate the highest term. So now from the general form, what is the leading term? The leading term always will be that the variable has the highest power of all terms, which is this term. So the leading term is a sub n x power n. And what is the degree? The degree is the highest power of the variable, whether the variable is in the front, in the middle, or the last. Always we look the highest power of all variable. So this one, this general form, the highest power is n. Why? Because each time the n is decreasing in n minus, let's say n is 4. 4 minus 1 becomes a 3. 4 minus 2 becomes a 2. Then and so on. So always we look the highest power, which is the n based on this form. What is the leading coefficient? Do not confuse leading coefficient and leading term. Leading term is entire term, first term of the highest power, but the leading coefficient is the numeric associated with the highest power term or the variable. As you can see, a sub n is the coefficient of x power n. So the leading coefficient is a sub n. Now let's go over this example, which asks finding the leading coefficient and the degree. That's all we are looking for. We're not looking for leading term. So on A, we have f of x equal 3x power 4 plus 2x minus 7. We can see clearly the highest power is 4, and the coefficient associated x power 4 is 3. So the leading coefficient is 3, and the degree, which is the highest, is 4. Now on B, y equal 12x minus 7x power 3 plus 11. Then we can see the highest power is x power 3, and the coefficient associated x power 3 is negative 7. And the degree of this polynomial function is 3. So on C is a different way of writing it because we can see clearly A and B whether we have a power of 4 or power of 3. But on C, we cannot see, we only have a 4. If you see a function equal to a numeric, always rewrite that function as g of x equal 4x power 0. Because x power 0 or anything power 0 is 1, we still have a 4 because 4 times 1 is 4. Now we can write which one is the leading coefficient and what is the degree. So the leading coefficient is 4 and the leading degree is a 0. So now we have a different concept other than leading coefficient or a degree. Now we're looking for the extreme. The extreme of a graph is the minimum and the maximum of the function. And there are two types of extrema, or two times that we can look for. One extrema is called relative extrema or local extrema. The other one is absolute extrema and global extrema. So what's the difference between relative and absolute? So a polynomial has a relative minimum and relative maximum where the graph is switches between decreasing and increasing it, or increasing and decreasing it, or at the end point. If there are endpoint of the polynomial has a restricted domain. If it doesn't have restricted domain, then we are not counting those points. But always when you look for this, we're looking for the x value unless the question asks where is that taking place. So now in this question we can see we're looking for local minimum. Local minimum is at the bottom of the graph. So we can see one local minimum. It will be this point and that point. Why are we choosing this? Because that's an endpoint. But on this side, you can see an arrow. So this graph is extending it all the way. We don't know where it will end. So the local minimum is -4, 0, which is those 2 points. What is the maximum? The local maximum or relative maximum or minimum, it will be this 2 point, which is -2 and 3. -2 and 3. So now we have the absolute extrema or the global. So of all local maxima, of all of them, the greatest will be called the absolute maximum and the least will be called the absolute minimum, or the greatest will be global or minimum or global maximum. So we are not looking in the middle, we're looking the highest point of the graph and the lowest point of the graph to find absolute extrema. So now we're finding it absolute maximum. The maximum takes place on this point and that point. Which one is the absolute maximum? -2 and 3. This will be the absolute maximum. So it's x3 and the y where the maximum is 2. At 2, but at x3. Do we have absolute minimum? No, we do not have, because we have, if it was ending, this is the at end point, but on the right side you can see the graph is extending it all the way to the right. Then that way we cannot assume this is the absolute minimum, so that will be a none. Or you can write NA. So now we have to classify each type of extrema of the function or write NA if there is none exist. So now we're looking at relative minimum. If you can see the relative minimum, there is no ending point on the left side, and then there is no ending point on the right side because the graph is extending it all the way to the left and all the way to the right. So the relative minimum is NA. Then what is the relative maximum? The relative maximum will be at this point, which is x equal to 1. What is the absolute minimum? There is no absolute minimum because the graph is the arrow showing extending left and right. So this is NA. So now what is the absolute maximum? This is the greatest maximum of the highest point we can reach of this graph is this point. Then that would be a 3 at x1. Three at x1. So now it's the same question, but now it's a different one because it has A, B, and C. So now we have this type of graph. If you can see this graph on the left, it has an ending point, but on the right side, it's extending all the way to the end. So what is the relative minimum? The relative minimum is this point alone, which is a negative 2. And relative maximum, it will be this point and the ending point here, because the graph is ending point here, so that will be negative 4, 3. Where is the absolute minimum? Absolute minimum, we're looking for where is the least. The least will be, if it was this ending on the right side, we could choose which one is the least. But as you can see that this graph is extending all the way, then there is no absolute minimum. Make sure you need to differentiate whether the question asking relative or local or absolute or the global. Now, what is the absolute maximum? Absolute maximum, this is the maximum then this point, so that takes place at S2 at 3. So now on this graph, if you can see, this graph has a left and right is ending point. It will end at 5. The interval is between negative 4 and 5. So what is the relative minimum? Relative minimum is always at the bottom, which is this point and that point. We're not looking for the absolute or the global, we're looking relative minimum. So that will be negative 3, 3. Make sure when the question asks relative minimum, maximum, global, we always look for the x, not the y, unless the question asks find where is that located. So now we're looking relative maximum. Let me use a different color so that relative maximum, one point will be here, another will be there, and we have a 3 different. Then it will be then negative 4, 0, 5. So now we're looking for absolute minimum. Which one is the lowest? Absolute minimum, we have negative 3 and 3. This is the absolute minimum, which is negative 3 and negative 3. And which one is the absolute maximum? Absolute maximum is negative 4, 0, and 5. So the absolute maximum takes place at 5, so x is 5, where the y is equal to 4. So now let's review some general about a polynomial. Between two real zero, how do we know where real 0 is? When we find the x-intercept, we're finding a real 0, unless we have imaginary number, but it's x. We look for the x-intercept of polynomial. There must be at least relative, I'm going to write a relative max or relative min. And number 2, a polynomial of even degree must have either absolute max, absolute maximum, or absolute minimum. If it's not the polynomial even, then we do not have absolute maximum or absolute minimum. So knowing these two concepts, let's go over this example. We have seen the point of inflection prior to this lesson, but let's go over one more time. A point of inflection takes place where the function changes from concave up to concave down, or concave down to concave up. It'll go concave up to concave down, or concave down to concave up. And a point of inflection, the rate of change, or just the slope. You can think about just the slope. The rate of change or the slope of a function changes from increasing it to decreasing it, or from decreasing it to increasing it. So now we are finding it on example 3. The graph of g of x is shown above. Use the graph of g of x to answer the following on A. Find any value of x where g has a point of inflection. Let me label it, increasing, decreasing it, so that we can clearly see what we're looking for. So we know we're decreasing from this point, and then we're increasing up to -1, and then we're starting it from -1, and then going to 1. I'll use different colors so that way I know where the inflection point takes place. And then the graph is going up. If you can see from the left side, it's a concave up. We have a concave up, concave down, and concave up. We have 3 different ways of switching the graph, so the graph must have 2 different points of inflection. One point of inflection is x equal -1. That's where the graph is switching concave up and concave down. And then x equal to a 1. That's where the graph is switching concave down and concave up. So the 2 points is in 1 and -1. This is the same question, but the question is asking a different thing to find out. Now we have, for each of the following interval, 3, 4, or -4, -3, -1, 1, 1, 2, determine the rate of change or the slope. Just the slope. Think about the slope of g is whether it's either increasing it or decreasing it. Explain your reasoning. Explain your reasoning. So I will be writing it I here to explain. I'll write a simple way. If you can see, we're looking for 3 and 4. Let me put a line 3 and 4. What do we see from interval 3 and 4? We can see the slope is increasing it. We can see the slope is increasing it. Why? Because it's concave up. Then I sub 2. I sub 2 is a -4 and -3. What do we see the slope? The slope, if you can see, is from the left, is keep increasing it, small, increasing it up to that, up to -3. So the slope is increasing because also concave up. So I3. So I3 is from -1 and 1. We can see the graph is concave down between these 2 values, which is -1 and 1. That's where we determined earlier question. So this is concave down. But it's a concave down, then the rate of change or the slope is decreasing because the rate of change is concave down. You can see clearly it's a concave down. This was concave up, concave up. So now let's look for the last one, which is 4. We label in a different color so that we can see clearly. Now we're looking 1 and 2. I will overlabel it 1 and 2. So from 1 and 2, we can see the graph is concave up. So the slope is increasing. The rate of change of the slope increasing it because is concave up. So always you just label it so that, or color it, use different colors so you can see what is the difference between each term.